want to take this opportunity to go over some of the rules that I've just recently realized. I was trying to memorize some common names for alkyl groups, and I found it really tricky to choose between something that was a sec group, something that was a tertiary group, and something that was a secondary group. But later on, I realized something, and it really helped me. And this is my attempt at documenting what I've learned. Hopefully, it'll help you too. So instead of memorizing the names, there's a much easier way to do this. And to test that my way works, we're going to go over all these names or all these formulas and see if we can get to the right names in this table. Let's do it. So the first thing is anything that ends with a forked tongue, like a snake forked tongue or a split tail, that right away is iso. So we can think of it more in a diagrammatic sense, and that might be a way better way to identify these things. And if it has three split hairs, or if it has, three tails, that's a tert, tertiary. That's short for tertiary. And if it has a split tail, but one of the tails is longer than the other by one, that's a sec for secondary. Now, these isogroups that, or these groups, not isogroups, these groups that use the naming iso, tertiary, or secondary, these are all common name groups. We won't see this really in the systematic naming convention. If we do see it in a systematic, it's probably a branch on a systematic name, but the branch has, for some reason, the branch is using the common name convention, whereas the overall name is a systematic name. So you may see it mixed like that. But other than that, this is really just used for common names. So even when we're naming the branch in a systematic name, it's still being used as a common name. So you see iso, you see tertiary, you see secondary, it's a common name. Okay, let's move on. So CH3, let's look at this one first. So for common names, we don't name the major chain by the backbone. We name the major chain by the total number of carbons. There's only one carbon here. So this is a methane that becomes a methyl. So that's just methyl. That's simple. Let's do the simple ones first. And here we have two carbons, right? So that's ethane, and that'll just become ethyl. Done. What else can we do? Now there's another straight chain. There's uh, propane, three carbons, right? And that becomes a 1, 2, 3. That becomes a propyl. So yep, that's fine. That's nothing new. Let's do a few more. Over here, you have a little bit to the rightmost. You have 5 and 6. So pentane and hexane. So pentane 5 will become pentyl. Hexane 6 will become hexyl. Good, done. And there's another easy one here. 1, 2, 3, 4. So that's just butane becomes butyl. Nothing magical here. We're not yet using iso, tertiary, or secondary. But let's use that now with what's remaining and prove that this works. So if you draw what you see right here in front of you, right here, let's do it. So there's some connection to something, we don't know what, but then there's two connections to two other carbons. What does that look like? That looks like a forked path, forked tail, split tongue, whatever. That's an iso. And the total number of carbons are 3. And in a common name, we care about the total. So it's a propyl, and we add the iso, and it becomes isopropyl. Let's take a look. Yeah, that works. Let's look here. There's a C carbon something here connected to carbon something here, then a forked tail. Okay, so it's an iso. But what? Iso what? 4 total carbons. Again, in a common name, it's not the backbone. If it was a backbone systematic, we would say 3 is the maximum. But no, this is a common name, so we count all the carbons. So it's a butyl, and since it's a butyl and it's an isobutyl. Let's take a look. Yeah, that works. Now let's look at the next one. There's a carbon, it has something forking off of it, another thing forking off of it, and something extra. Okay, that looks like secondary over here, right? Because there's a forked tail, but one part of the tail is longer than the other, so that's got to be sec for secondary. And the total number of carbons are 1, 2, 3, 4. What does that make it? Let's think about it. 1, 2, 3, 4. That's again a butane, butyl, and sec-butyl, right? Put the two together, sec-butyl. Works. Okay. Now you got a carbon, and you got, if you look at it, you got that pattern of a tail split into 3 parts, and that's tertiary, right? So that's just tertiary, and then the 4 carbons, that's just butyl, tert butyl. Yeah, and we're done. And we put a minus sign or dash between sec and tert, but iso just gets glued onto the word, whether it's butyl or whatever. Let's keep going. We know this is pentyl, all the molecules have stuck to the previous. So we know this is a pentyl right here, 5 total, not the backbone, the whole thing. This is a common name. So there's 5 of them. We know it's pentyl, and we know there's a forked tongue here, right? There. 1, 2, 3, 4, 5, and there's a fork at the end. So it's got to be isopentyl. Let's take a peek. Yeah, it's isopentyl. Same thing with hexyl. Let's do it. 1, 2, 3, 4, and then there's a fork, and that fork is equal length. That's that's iso right there. So that's isohexyl probably, and that's right. Now let me just do one more thing. What if we added a tail here, right? Like we made the split tails or the split tongues uneven. Right away we know it's sec, but it's not sec pentyl and sec hexyl. If you take a look at it, I mean the one above, it's not 5 carbons anymore. It's 6 carbon. 1, 2, 3, 4, 5, 6. I added an extra carbon, so this would be sec hexyl, right? And I had 6 here, and I added an extra carbon with the uneven tail or the uneven forked tongue. So that's now sec heptane heptyl. Okay, this is SEC. If you don't understand my handwriting, that's secondary heptyl, sec heptyl with a minus sign or a dash between them. And that's everything I've realized so far about differentiating iso, tert, and sec from each other.